So we're going to look at problems from chapter 6. So in chapter 6 we're looking at bond pricing. So the first problem we want to look at is just a basic problem, giving us an overview of what a bond contract looks like. So this is a typical bond contract cash flow. You have periodic payments, what we call the coupon payments, which is a percentage of the par value. And then at the end of the bond's life, you have both the coupon payment as well as the face value or the principal of the bond being repaid. So in this question, what is the maturity of the bond? It's 20 years. What is the coupon rate in percentage? Coupon is a percentage of the par value. So coupon is coupon rate times par value. So coupon is 20. Coupon rate we do not know, times the par value. So C is going to be 0.2, which is it's going to be 0.02. .02 or 2%. So the coupon rate is 2%. And what is the face value? The face value is usually $1,000, as it is in this case. Okay, the next question we're looking at a zero coupon bond. A zero coupon bond is, as the name implies, the bond does not pay any coupon today in the interim, and at the end of the bond's life, it pays back the principal or the face value. So the price or value of this bond today is simply going to be the present value of F at time t, whatever time t is when the bond matures. T or N, whichever way you want to characterize it. So B0 would simply be the present value of Ft, which is going to be the face value at time t, that maturity, divided by 1 plus r to the power t. So that will give us the price of the bond. So what is the price per $100 face value of a 2-year zero coupon risk-free bond? So this problem says that if a bond has a maturity of 2 years, its yield to maturity is 5%, 5.5%. So the price of a $100 face value bond would be 100 divided by 1 plus 0.055 raised to the power 2 years of maturity. Another way we could have solved this is we make 100 our future value. IY is our yield, 5.5% per year. And we have 2 periods, N. We compute present value. So we could do it that way. So bringing back our financial calculator. We clear everything, clear TVM. So 100 is future value. 5.5 is IY. 2 is N. And we are going to compute present value. So it will be 89.84. So as you can see, zero coupon bonds are also discount bonds. They are discount bonds because they sell at a price below the par value of 100. They will always do that. Right? They will always sell below par value because $100 of the face value will be paid in the future. The value of something in the future today will be less than what it is in the future. $1 today is worth more than $1 today. $1 today is worth more than $1 in the future. Okay, so that's, let's see, that's problem number 5. Okay, Let's look at the next problem. We have a bond with the yield to maturity of a bond, $1,000 par. So that gives us the face value or our future value. This is our yield, that's our IY. It's semi-annual coupon, so it's semi-annual compounding. 2 years to maturity, so N is equal to 2. And it's, no, that's not IY, hold on. Made a mistake over here. That's our coupon. That's our coupon C. That's our coupon C, and this is our IY. This is our yield. What must be its price today? So we have a $1,000 bond, 2 years to maturity. That means at maturity, this bond will pay $1,000. However, in the interim, this bond will have 2 coupon payments, and the coupon payments are going to be 7%, which is 7% of 1,000, which is 70, and 70, 7% of 1,000. So coupon is going to be the coupon rate times the par value, which is going to be 0.07 times 1,000, which is $70. 2 years to maturity, and our, but over here, notice over here, this is a semi-annual bond. Being a semi-annual bond, the bond is not going to be paying $70 per year, it is going to be paying $35 every 6 months. So it's going to be 35, 35, 35, and 35. So it's 2 years, but it's going to be 1, 2, 3, 4 per 1, 2, 3, 4 periods. And the interest rate, the APR over each year is 7.6%. However, the interest rate over each period is going to be 7.6 divided by 2. So we will have payment in our cash flows. We'll put payment as 35. IY would be 7.6 divided by 2. N will be 4. There are 4 periods. FV will be 1,000. And once we have this, we will compute present value. So we go over here, we clear everything. Second, clear TVM. 35 is our payment. 4 is N. 7.6 divided by 2 is 3.8. That's our IY. 1,000 is our future value. We compute present value 989. So present value is 989, which means the price of the bond is 989. Okay. Let's look at another problem over here. GE issued a bond with 10 years until maturity and a face value of 1,000. Okay. It has a coupon rate of 7%. So this 1,000 represents my future value. Coupon rate of 7%, that's my C. It says annual payment, so this is an annual bond. The yield to maturity of the bond when it was issued was 6%, so that's my IY. So what is the price of the bond when it was issued? So we can put this on our timeline formulas. Payment, which is our coupon, which is going to be 7%, 7% off par. So it's 7% off 1,000, which is 70. IY is 6%. This is annual, so we don't need to change that. Future value is 1,000, and there are 10 years to maturity. So what will be the price of this bond? So we enter all of that into our financial calculator, and we compute present value. So let's take a look at it. Clear everything. Second clear TVM. 70 is payment. 1,000 future value. 10 is our N, and 6 is our IY. Compute present value. That's 1,073.60. So present value equals the price of the bond, 1,073.60. That's pretty straightforward. And we can see some relational points over here. The fact that the coupon is above the required rate of return, or the yield, makes the price of the bond exceed its par value. So we also describe a bond like this as a premium bond. Had payment been less than IY, coupon being less than IY, then this bond would have been selling at a discount, meaning it would be selling at a price less than $1,000. Question number 20, using the same example, assume the yield to maturity remains constant, so there is no change in IY. Okay, so IY remains constant. What will be the price of the bond immediately after it makes its first coupon payment? So after the first coupon payment, what's the only change that's happening? The only change that's happening is that after the first coupon payment, we have only 9 periods left to maturity. We're still going to have 9 more coupon payments plus the $1,000. So if we go back over here, keep everything the same, and change N to 9 and recompute present value, we get the present value as 1,068. So the new price of the bond would be 1,068. So notice what's happening then. As we are moving forward through the life of the bond, we go from 10 years to maturity to 9 years to maturity. Everything else has remained the same, no change anywhere else, except of course time. What happens to the price of the bond? The price of the bond drops. So there is a natural decay in the pricing of the bond as it progresses through time. But this natural decay occurs if the bond is a premium bond. So much such that by the time the bond is very close to its maturity, the price of this bond is going to converge to $1,000 once it is very close to maturity. Had this been a discount bond, so you can try this. Had this been a discount bond, instead of using 7% over here, let's say you use 5%. Okay, so let's try this over here. Clear everything. We are going to use a 5%. That means our coupon payment is going to be 50. So we will have 50 as our payment, and we will first try N as 10, and we will compute present value. So as I mentioned, this bond is now a discount bond. 926 is the price of the bond. Had coupon been 5%. Now, once we are into the life of the bond, after the first payment has been made, now we have only 9 years left to maturity. So we change N to 9 and compute the price of the bond again. Notice what happens. The price of the bond this time goes up as opposed to previously when the price of the bond went down. Again, what will happen? This price of the bond is going to slowly increase to 1,000 as the closer we get to maturity. So the general behavior of the price of the bond over time is that discount bonds will go down in time as we get close to maturity, and premium bonds will go down in time as we get close to maturity, and discount bonds will increase in time as we get close to maturity. So this is going to be the behavior of discount bond, and this is going to be the behavior of premium bonds. Okay, let's get to the next problem. Over here, the question is what happens when yield to maturity changes? So we are looking at a problem with different, for which we have different coupon rates and different maturities. So let's take this one first. The coupon rate is 4%, maturity is 15 years. So let's take bond C. So payment for bond C is 4%, which is 4% of 1,000, which is 40. We are assuming these to be annual bonds. N is going to be 15. Yield to maturity initially is 6%, and future value is going to be 1,000. We'll assume a future value of, we could do 1,000, we could do 100, doesn't matter. So let's use 100, because I think the book tries to use 100 as the number. So we'll use 100 as the future value, or the par, or the face value, or the par value of the bond. So once we have this, we can compute present value. And once we compute present value, so we go over here, clear everything, second clear TBM. 100 is future value. 15 is our N. 6 is IY. And 40 is our payment. So we compute present value. The price of this bond is 430. Something is wrong with this number. So let's try it again. Second clear TBM, maybe something did not get cleared properly. So 40 is payment, 15 is N, 6 is IY, 100 is future value. I'm going to compute present value. $100 future value. That's what I'm making a mistake. If I'm going to be using future value, I should use future value as 1,000, not as 100, as I've been using before. So we'll use 1,000, because if I use future value as 100, then coupon would have to be 4. So we will go back, second clear TBM, 1,000 is our future value, 40 is our payment, 15 is N, 6 is IY. Now we compute present value, so that gives us 805. That makes sense. 805. Again, sometimes you can use logic to even check your work. That 430 would not be possible, because if the price of the bond, if the face value is 100, the price of the bond cannot be so much larger than the face value, particularly given the fact that the payment is less than the required rate of return or yield. So the fact that our payment or coupon is less than IY, we would expect this bond to sell at a discount. So we got that. Now we're going to keep everything else the same and drop the yield from 6% to 5%. So change this to 5%. So we go back over here, 5%, change IY to 5%, and we will compute present value. And what happens? The price of the bond increases to $8.96. So it illustrates for us the general relationship between bond price and interest rate. When interest rate drops, bond prices go up. The inverse relationship between bond prices and interest rate. Vice versa, if interest rate were to increase, the price of the bond would decrease. So question over number 24, which bond is most sensitive to a 1% drop in yield from 6% to 5%? Which bond is least sensitive? If you work out, if you want to find out sensitivity, then what you would have to evaluate is the percentage change in the bond price. So for this bond, we were looking at bond C. The initial bond price was 805. Change in bond price, we call it B1. Change in bond price is 896. So this is the end price. This is the beginning price. So we calculate percentage change as ending price minus beginning price divided by beginning price. So that's the, and we multiply this by 100. That will give us the percentage change in the bond price, which will be about 11.2%. So similarly, you can work out the percentage change in the bond price for A, B, and D. And if you do the math, it comes out to be that A would have a 15% change, B would have a 9%, about a 10% change, C has an 11% change, and D has a 7.4% change. And the math is pretty straightforward and simple. But the question that is interesting over here is provide an intuitive explanation as to why that would be the case. Notice that the bond that has that is least sensitive to changes in yield or changes in interest rate also happens to have the largest coupon. So the larger the coupon, lesser the sensitivity to interest rate changes. The bond that had the highest change in its price also had the lowest coupon. And between these two bonds, both 0% bonds, zero coupon bonds, the only difference, larger maturity, lower maturity. The bond with the larger maturity also had the highest sensitivity to interest rate changes. And that should make intuitive sense because longer the maturity, that means you are committed into the investment for a longer period of time, and thus any changes in interest rate increases your volatility, increases your risk because you are locked into that interest rate. And volatility works both ways. If the interest rate goes down, prices will go up. If interest rate goes up, prices will fall. But in other words, the price change, what we are looking at over here is the delta, is the change in the price of the bond. And that gives us a measure of volatility. Okay, so that completes for us the problem tutorial on bond pricing.